Hello, my name is Heidi Schutz, and I will be presenting my research proposal in assessing habitual caffeine intake on resistance-trained females. Caffeine is dubbed as one of the most utilized ergogenic or physical performance enhancing supplements. It is found in various naturally derived common food items such as coffee, tea, and carbonated beverages. It's approximated that caffeine consumption is 90% within U.S. adults, consuming around 200 milligrams of caffeine per day. It's a popular substance among individuals due to its stimulant properties on the central nervous system, which can enhance one's alertness, attention, and cognitive performance. The ergogenic effects have been described among numerous researchers, demonstrating the positive role caffeine may play in athletic performance. Various sectors of the fitness community use caffeine as an ergogenic aid in training and athletic competition, ranging from mixed martial arts to group sports to cycling, sprinting, and modalities of resistance training. Research has focused on various levels of caffeine ingestion to determine optimal dosing for different fitness practitioners. It is well established that low to moderate doses of caffeine can have an ergogenic effect on endurance performance. With the rise of fitness trends such as wearable technology, group training, exercises such as CrossFit and boxing, as well as streaming workouts, resistance training has steadily increased over the years, with women beginning to acknowledge the benefits that resistance training may provide. There is limited evidence regarding the influence of habitual caffeine consumption and more acute effects of caffeine supplementation on exercise performance, but based on available research, there's evidence that supporting habitual caffeine intake may have on exercise performance. As widely studied as caffeine is, the majority of the research is focused on the male population, with current research identifying women as comprising 13.2% of total samples. Gender has also been identified as an important determinant of athletic performance by way of body composition, aerobic and anaerobic capacity thresholds, and thus recommendations for each gender should be tailored uniquely to allow for the best possible results in sports performance. With the bulk of literature concentrating on caffeine's positive effects on resistance-trained men, a need exists to explore the potential ergogenic benefits on the female population, particularly with focuses on resistance training and muscular endurance. Thus, my research question will aim to seek, does habitual caffeine intake lead to an increase in muscular endurance in resistance-trained females aged 25 to 35? The focus here will be on habitual caffeine intake, as most studies have studied it on men only and not females. Furthermore, another additional focus will be on muscular endurance. The different fitness facets that have been studied include aerobic and anaerobic type of exercises. Muscular endurance, which falls underneath the anaerobic capacity, will have a particular emphasis. A review of the literature shows there have been cumulatively positive effects on exercise performance. There's differences between the aerobic and anaerobic studies, and literature has described positive effects for several categories within each of these aerobic and anaerobic headings. Under aerobic, short high-intensity interval training, swimming, and cycling have all been published. And anaerobic, weightlifting, vertical jump height, sprinting, and resistance training have all been described in the literature. Dosages have been studied at various levels, all at safe. The consensus of literature does show low to moderate dosaging consisting of 3 to 6 milligrams per kilogram of body weight to be ergogenic. This is equivalent to 2 to 4 cups of coffee. Habitual versus acute users have also been described in the literature, although conflicting evidence has been found. The beneficial effects of caffeine on exercise performance is less apparent in the female populations. There's definitely a shortage of females being studied compared to their male counterpart, especially with regard to resistance training. Caffeine has been found to increase time trial performance, strength performance, and endurance performance in both populations. A systematic review evaluated differences between genders with caffeine supplementation, highlighting the differences between muscle power and speed among genders to be a major finding. A more recent finding found that caffeine improved tolerance to exhaustion and improved strength in young women. The first study, though, to investigate caffeine supplementation in resistance-trained women was conducted by Goldstein et al., which I will seek to replicate the study. Although Goldstein et al. Was able to find that the dosage of 6 milligrams per kilogram was effective for enhancing strength, they found that it did not enhance muscular endurance. This will be a finding that I will seek to counterpart and hopefully add to the knowledge that resistance-trained women can enhance muscular endurance through caffeine supplementation that has been demonstrated in literature in the male population. My methodology will consist of using a quantitative design, particularly an experimental, double-blind, randomized, placebo-controlled crossover design. Each participant will serve as his or her own control. The supplementation protocol will consist of 2 exercise trials, one with habituated caffeine users and one without. And the testing protocol will be a series of maximum amount of push-ups completed in 1 visit. This will be used to assess muscular endurance. The participants will be randomly assigned to either their control group of being non-caffeine users or intervention group as the habituated caffeine users to reduce the risk of statistical bias. A paired t-test will be used to determine any significance in the collected data. G-power testing will be used to determine the ideal sample size needed to see significance prior to recruiting these participants. Based on the paired t-test, the null hypothesis will be rejected if the p-value is less than or equal to 0.05, as this adheres to best practice. For data collection, habitual caffeine intake will be used from an adapted food frequency questionnaire utilized in a previous study conducted by Wilk et al. A health history questionnaire will also be utilized to assess for the participants' overall health, including inclusionary and exclusionary criteria. A dietary log to log all appropriate food intake will be used through online chronometer. A push-up counter supervised by nutritionists will also be on site at the gym. Informed consent will absolutely be given to each participant, which will give an overview of the entire study design, the risks, the benefits, the data collection and storage, contact information, as well as the consent statement. And all of the data collected will be approved by the IRB prior to this data collected. Recruitment will be through various modes consisting of posters, flyers, emails, sign-up sheets in local gyms, recreational facilities, CrossFit gyms, and local coffee and vitamin supplement shops. The ideal amount of participants we are looking to get is 30 as conducted in previous studies. This will be the example of the adapted food frequency questionnaire that we will use, and the food frequency questionnaire will be completed individually with the supervision of a qualified nutritionist. It'll be employed to assess the habitual consumption of dietary products containing caffeine, which will give us an idea of who will fit in the habituated caffeine user category. Analysis will include statistical weighs by one-way ANOVA. Data will be assessed for normality, with normal data being described by mean and standard deviation, and non-normal data being described by ways of median and interquartile range. Descriptive statistics will also be used to describe the study population, with again the null hypothesis rejected if the p-value is less than 0.05. Strengths of the study include contribution to literature in underrepresented population, that being the females, also further elucidating gender differences in dosing. Limitations include variability in caffeine habituation, confounding variables such as genetic factors, such as polymorphisms that can depend on how they metabolize caffeine, affect how it's bioavailable to them, and also the menstrual cycle. Inaccuracy in dietary logging may also be problematic. For future research, optimal dose of caffeine for women needs to be considered. There's definitely there's equivocal findings about which dosage is best, and this warrants further research to find the best dose for each individual. Gender differences and responses to aerobic versus anaerobic activity will also be something to be considered in future research. Both aerobic versus anaerobic activity have had its own merit and benefits, but more elucidation needs to occur for these to be given as public knowledge. Lastly, the menstrual cycle is also something that needs to be considered, as this is something that has not been studied and could be an important confounding variable for future studies. In addition, differences in the response to dietary supplements should also be investigated to ascertain whether findings of previous investigations with males are also applicable to women athletes. And it is of great importance to continue the work in future research on supplementation with caffeine in female populations. It is necessary to determine whether women athletes benefit from acute caffeine intake in other forms of exercise or in sports where several physical fitness variables affect overall performance. Lastly, athletes, coaches, and practitioners that are looking to use caffeine as a means to enhance performance would be best placed to experiment with various different caffeine doses to determine the optimal dose to enhance their performance, given their own unique biology, history, and performance requirements. Thank you so much.